All right, I'm going to do this one for sure. I may or may not do the last example. We'll see how much time this one takes. All right, so f of x equals 5x. What's that look like? A line. Yeah. Okay, so we have a line, slope of 5, y-intercept of 0, so a steeper line. We could get more precise if we really cared. G of x is x squared. What's that? All right. We want R to be the region between the graphs of f and g on the interval 0 to 3. So at 0, they're touching. At 3, are these things equal? 5 times 3 is 15. 3 squared is 9. So they're not equal there, but that's okay. That's just our stopping point. So it's like, I'm going to start at 0. I'm going to end this thing at 3. So my area is between those. And I am rotating that around the x-axis. So I told you if you're struggling with how to rotate, think of it as a reflection first. Like that. So we're getting our funnel again. When we do this, are we going to do things in terms of x or y? X. When did I tell you to do y's? If it goes around a vertical line, like the y-axis. Alright, so we are going to start at 0, end at 3. Pi. Okay, this one has 2 curves, so we have to do each radius squared. Right, so the outside is the line, so that was 5x. The inside is my parabola, so that was x squared. If you're rotating around a line other than an axis. So if I said you're rotating around x equals 3 or y equals -2, then you have to measure your radius from that line, not just the axis. So we could have our pi. This would be 25x squared minus x to the 4th dx. Okay, antiderivative of 25x squared would be minus 1/5 x to the 5th. Alright, so then if we plug in 27. This one doesn't turn out real pretty. So we get 882 over 5. So 882 pi over 5. The last one, I'm not giving you any problems like this one, but I just wanted to show you, we have been integrating everything with a curve, so I just wanted to do at least one problem where it wasn't a curve, just to show you this still works. So suppose we have a pyramid, 4 units tall, with a square base, 3 units on a side. Find the volume of the pyramid. Okay, so pyramid, this is really going to test my drawing ability here. And we know that total height of this is 4. The base is a square, so it's 3 on each of these sides. So if I want to picture this with an axis, like try to visualize if this thing were placed, so it's 3-dimensional, right? So it's sitting where the base is sitting on the x-axis and going up from there. How would I find the volume? So if we're going up, are we integrating with x's or y's? Y's. We use x when we go around a horizontal. Here we're starting at the bottom and going up, so that's a vertical. So we have to do everything in terms of y. If we think about a cross section here, so the cross section, what shape would our cross section turn out to be? Square. So we need a formula for the length of the sides of that square to integrate. So we're going to go from, let me leave myself a little room to work. We'll integrate from 0. So if this is starting at 0, we know it's 4 units tall. We'll integrate from 0 to 4. If the side or the cross section is a square, how do you find area of a square? Length times width, and they're the same, so it's just that side squared dy. So we just need to find that formula. To do that, we could think of similar triangles. So this whole face, okay, that whole triangle, the height of it was 4 and the side was 3. If we take that little triangle, okay, so the height of this, let's kind of visualize. So the height is the top, right? So if it starts at 0 and ends at 4, the height of that is like wherever we are on the y-axis. That would be like our y. So if I think from here to here is y, what would from here to here be? Would be 4 minus y. So the height of this is 4 minus y. Because we know the whole height is 4, and the height that you've traveled up so far is y, because you're moving along the y-axis. All right, we need something to call this. Let's just call it A for a second. We could use similar triangles here, because we're trying to find this piece, right? So if we do similar triangles, we could say 4 over 3. So the height over the base is the height of my small one, 4 minus y over the base. A. A is what I'm trying to solve for here. So if we cross multiply, divide by 4, so we get 3 minus 3/4 y. So that is the length of the side. So if I were going to integrate this, what should we do first? Let me multiply it out. That would give me a 9. Minus 9/4 and minus 9/4, so minus 9 halves y. Plus 9 over 16y squared. So antiderivative of y would be 9y. Should be 9y squared. This goes to y cubed, so if we multiply by 1/3, 3/16y cubed. Oh, plug them in. And then comes first. Hold on, I messed up, didn't I? Yeah. Do you guys know how I found I messed up? My final answer is going to be negative. And we can't have that, can we? So we get, oh. So this was just kind of a side note because I know you guys really care. This is just showing you that this strategy doesn't only work for curves. It works for other shapes as well. But the ones I'm giving you are all the curve type problems. So, you guys have, I've already given you, the first 6 problems, and hopefully you've been working on those and getting them done. So I'm adding 3 final problems. This is going to be due Thursday. I am also going to go ahead and give you a handout. So we probably would have taken 2 days to work on this in class, but since nobody's here tomorrow, you're only going to get 1 day in class. Okay, that's my compromise. So I'm not teaching anything new, but you lose a work day. So I will go ahead and give the handout today in case anyone wants to start it. The handout, we will have a work day on Thursday for that, and it's due on